proximal carpal row and the distal parts of the forelimb bones. And so a consequence of this is that you see there's a lot more space here on the ulnar side. There's a lot less bone here, so you actually can ulnarly deviate the hand to a much greater range of motion than you can on the radial side. You can see for yourself that the range of motion here on this side is much greater, and that's a consequence of there just being less bony anatomy there to stop that motion. The elbow joint, quote unquote elbow joint, is actually a joint complex of three separate joints. So there's the sort of familiar hinge joint, the humeral ulnar joint, listed as number 1 here between the humerus and the ulna. There's also a humeroradial joint, which is technically a ball and socket joint, but very limited in that it's sort of wrapped with all these collateral ligaments that restrict its motion, and it essentially just helps participate in flexion extension along with the first joint here. And finally, the third joint is the proximal radioulnar joint, which is part of that pivot joint where the head of the radius will slide across the ulna for that supination, pronation motion. Okay, so and this slide I don't think I added yet, but I'll post the updated version on Seabase. Motions at the elbow are restricted by these joints. So you have here on the radial side a collateral ligament. There's one on the ulnar side as well. And then there's this annular ligament. Annulus means ring in Latin. So this ring-shaped ligament that keeps the radial head from dislocating, a very important ligament. The shoulder, the glenohumeral joint, or the shoulder joint, is a highly incongruent joint. That is to say, there's a big difference in the shape and size of the humeral head and the glenoid fossa, which is right here, and that's part of why it's so mobile. And because it's so mobile, it's the most dislocated joint. Has anyone dislocated their shoulder before? No? Just me? Eight times? Okay. Fine. It hurts. But so it's a very mobile joint, and it needs to be reinforced by various ligaments, various muscles. And you can see here the cutaway tendons of the these are all the rotator cuff muscles. And you can see they stabilize the joint posteriorly, they stabilize it anteriorly. Here's a schematic of this in the anatomical position when you're just sort of sitting like this. You have good coverage from all these muscular tendons to keep that joint in place. Here, down here, this is an elevated and abducted posture, so sort of standing like this, for instance. And when the shoulder is in this condition, it's actually in its most vulnerable state, because you can see here there's no sort of anterior reinforcement to the joint. So if you're standing like this and you get hit from the back forcefully, it's very common that the shoulder will dislocate anteriorly and inferiorly, and that's happened to me several times. So this will come out anteriorly like that, and when that happens, you're in danger of compressing a nerve called the axillary nerve. And with that, let's talk about all the nerves. So there's a bunch of nerves in the upper limb. This is a sort of a colorful schematic of the plexus of nerves at the root of the neck and the proximal part of the upper limb, called the brachial plexus. And as you can see, the brachial plexus receives contributions from the ventral rami. These are ventral rami, from C5 to T1. Okay, so you get the ventral rami coming in and sort of forming what we call the roots of the brachial plexus, and you'll see these in my prosection, and they'll be way up in the root of the neck. So not in the upper limb at all, but you have to look at the neck to see those. And then the roots will form distinct trunks. Okay, so as you can see, C5 and C6 will fuse together and form a trunk right here. C7 goes all by itself and has a trunk right here. And C8 and T1 will fuse and form their own trunk. These will be the superior, middle, and inferior trunks. from there, you'll have what are called divisions between the trunks and what are called cords. And the divisions are right here, so there's a bunch of what are called anterior and posterior divisions, okay? So, and I'll have another slide where these are all labeled, but I just show it here in sort of an uncluttered form, but they're basically these little nerves right here. So these three divisions sort of unite and form this big nerve right here, which is called the posterior cord. And then these two right here come together and form the lateral cord and the medial cord down here. Okay, so these are the cords, the three cords, which are pretty easy to understand. I mean, they just exist as these things distal to the divisions. You have then what are called branches or terminal branches, and these are the actual nerves you'll see in the upper limb. And you'll see the terminal ends of the brachial plexus, and I'll show you those on a separate slide. So here's the same exact thing, just drawn a little bit more true to life from Netter's. So again, you have the ventral rami right here in the root of the neck. You have the superior, middle, and inferior trunks. You have a bunch of divisions. So from here on, going forward in the talk, anything that's like an anterior division nerve that's innervating an anterior division muscle will be in blue, and anything posterior division will be in orange. Okay, so these correspond to muscular compartments that you'll see soon. So there's three posterior divisions that make up this posterior cord. There's two anterior divisions here for this cord and one for the medial cord. So here they are, the lateral, posterior, and medial cords of the brachial plexus. And then the cords change their names to terminal nerves after they give off these roots. So there's these roots here, not to be confused with these roots way back here, but these are roots of what is called the median nerve, which is a big major nerve of the upper limb. So that you would say the lateral and medial cords each send a lateral and medial root to the median nerve. And after that's given off, you have this big M here, which is an important landmark in the brachial plexus. So when you go to the prosection, the first thing you want to do when you see the brachial plexus is look for this big M, which will hopefully look like that in the body, or I'll cut it to make it look like that. But when you find this, you will see it. When you find this, you'll say, aha, okay, I go lateral, I know I have my musculocutaneous nerve. I go right in the middle, that's obviously going to be the median nerve. That's where it gets its name. And if I go even more medial, you have the ulnar nerve, the medial most one of these big anterior compartment nerves. These posterior compartment nerves, you're going to have to dig deeper for them, obviously, because they're going to posterior compartments. They're going to the shoulder. In the case of the axillary nerve, they're going to the posterior arm. In the case of the radial nerve. So these are the five big terminal nerves that stem from this arrangement of nerves we call the brachial plexus. Okay, so again, you have these anterior compartment muscles that are innervated by these three nerves, and posterior compartment muscles that are innervated by these two nerves. Okay, so after that, so these are the main nerves of the brachial plexus, but there are also a couple of important little twigs from the plexus that I point out here. There's a long thoracic nerve here that goes to a muscle we've already seen, serratus anterior. We have the pectoral nerves that we saw way back 4 weeks ago. We found medial and lateral pectoral nerves, which did not have a real medial-lateral relationship in the thorax. But now you see here in the brachial plexus, they're named after the cords they come off of, so that the medial pectoral nerve is coming off the medial cord of the brachial plexus, and the lateral pectoral nerve comes off the lateral cord of the brachial. So you'll see these again as well. And finally, there's three twigs off of the posterior cord that I will attempt to dissect, and these will be various subscapular nerves. And these subscapular nerves are posterior compartment nerves that go to a bunch of shoulder muscles, well, latissimus, and then a bunch of shoulder muscles, essentially. Okay, so tomorrow or later today, the pro section will be done by 4 or 5, so if you even want to go later today, you should be able to find all these nerves. Okay, so again, I said these nerves go to various muscular compartments in the upper limb. And so here again is a simplified schematic of the brachial plexus, and you'll see these blue nerves innervate these blue territories, as you can see in these axial sections, these transverse sections of the upper limb. So here's a very proximal transverse section in the upper limb going through the humerus here. So this is in the arm. And the anterior part of the arm up here is innervated entirely without exception by this nerve called musculocutaneous nerve. So if you know that, this will save you time. You don't need to memorize a huge table of nerves if you can compartmentalize this into these sort of muscular compartments. You'll already know anterior arm, it has to be musculocutaneous nerve. Posterior arm, it has to be radial nerve. Going into the forearm, lower down, posterior is still radial nerve. So the posterior compartment of the arm and forearm is really easy because it's all radial nerve innervation with minor exception. And the forearm, again, musculocutaneous in the arm. In the forearm, the median nerve takes over as the major nerve. And the median nerve will innervate most of the muscles of the forearm, with 2 exceptions done by the ulnar nerve. This pattern then switches in the hand, where the ulnar nerve will become the major nerve of muscular innervation in the hand. And then the median nerve will just do a couple of thumb muscles at what's called the thenar eminence, and I'll show you that. Notice that there's no orange in the hand, and that's because there's no posterior compartment intrinsic musculature in the hand. So that's all blue in the hand, all anterior compartment. So that was all motor innervation, everything having to do with motor innervation of the upper limb. And now a couple slides just on the cutaneous innervation of the upper limb. So you see that these are cutaneous parts of the brachial plexus, most of them, except for this one right here, which is T2, which you know is after the brachial plexus, which ends at T1. But you have the axillary nerve, which again is around the shoulder, so it sort of does some cutaneous innervation in and around the anterior-posterior shoulder. The radial nerve has a lot of coverage posteriorly. There's a lot of cutaneous innervation of the arm, forearm, and of the hand posteriorly. And then there's a couple of nerves that you'll also see in dissection. Look for this medial cutaneous nerve of the forearm, which you should see off of the medial cord of the brachial plexus, and likewise the lateral cutaneous nerve of the forearm of the lateral cord of the brachial plexus. Okay. The hand, so zooming in on the hand here, the hand has a sort of a complex innervation scheme where most of it is median nerve here, so the thumb and the sort of the first 3.5 digits, I guess you could say, is median nerve, and then the pinky and then part of the 4th digit is done by the ulnar nerve. And then you have a little territory here on the palmar side from the radial nerve, or what you would call at this point the superficial branch of the radial nerve, and then a bunch of the dorsum of the hand innervated by the radial nerve as well. Cutaneous branches from the radial nerve. Okay, so that's the innervation setup of the upper limb, and let's see how that relates to muscular innervation and muscular action. So these muscles right here, deltoid, are posterior compartment muscles. This is innervated by the axillary nerve. Pec major, obviously an anterior compartment muscle. And okay, so when you're thinking about muscle action, you can memorize a huge table of muscle action if you want. But the way I'm going to present it is in a more compartmentalized way, in a way that you sort of can deduce muscle action based on certain common traits, location and regions of these muscles. So for this one, muscles that are anterior to the shoulder joint. So any muscle that crosses the shoulder joint from an anterior approach is going to be a flexor of the arm. Okay, so that includes pectoralis, which is certainly anterior to the shoulder joint, and part of the deltoid. You see in this rotating figure these red fibers right here. That anterior most part of the deltoid is also going to be able to flex at the arm. Deltoid is a complicated muscle that has a bunch of action, but the anterior part, as you can see right here in this cartoon as well, is also going to add to flexion at the shoulder. Muscles that are posterior to the shoulder joint are going to do the opposite. They're going to extend. So if you have muscles that are contracting posterior to the shoulder, they're going to bring that arm into extension. And that includes the latissimus, the teres major, and the posterior part of the deltoid. So deltoid can flex and extend at the shoulder. Okay? The muscles that are inferior, below the shoulder joint, are going to be adductors. Okay, they're going to swing the arm towards the torso. Okay, and that includes these three muscles that I said we're attaching at a very similar location on the humerus. These three guys, the lady between two majors, so the latissimus, the pec major, and the teres major, are all going to be adductors. Okay, because they all are inserting right around here on the proximal humerus, and this red dot is supposed to be where the shoulder joint is. So regardless of whether you're in front of the shoulder joint or behind the shoulder joint, if you're below it, you're going to contribute to adduction. If you are superior to the shoulder joint, if you're above the shoulder joint, you're going to do the opposite. You're going to abduct. So if you're pulling at the shoulder from above, you're going to have this tendency to swing the arm outward. And that includes the middle fibers of the deltoid, okay, as well as this little muscle here called supraspinatus, this guy right up here. So supraspinatus, a rotator cuff muscle, and the middle part of the deltoid are both going to abduct the arm because they're attaching from above. This one's a little more complicated, but essentially muscles that approach the shoulder joint or the long axis of the arm at an angle are going to rotate the arm in some way. So if you're approaching this joint at an angle, which is certainly a